Okay, so today we're going to be covering solving multi-step equations. Now, the cool thing about how I'm filming these is I'm just filming what we're covering in class. And I've noticed these overhead fluorescent lights make me look like I got hit by a truck. So I'm not just worn out and tired, it is the lighting. However, I might just be worn out and tired. I am kind of getting up there in years, so we'll see. But let's go ahead and get started today. So if you weren't here for today, we're covering section 1-2, solving multi-step equations. This kind of picks up where our last few questions left off, where we're starting to see, okay, I have variables on one side, on both sides, how do I do the isolation process? And we're gonna see there's two different ways to do it. One where we simplify one side and the other side and then isolate the variable, and others where we can kind of pick and choose when we isolate and then simplify if we do it all. So let's go ahead and take a look. So, title is Solving Multi-Step Equations. So, when solving an expression, it means we simplify using PEMDAS. So solving an expression means we simplify we can simplify each side of an equation using the same process. So we're going to simplify the left side and the right side using PEMDAS. So again, the concepts that we know here is expression versus equation. An expression is something that doesn't have an equal sign. It doesn't necessarily need to have any sort of value, although sometimes it does. What an equation does is it pits an expression and an expression and says they are equivalent, so we say that they are equal. So I can simplify and I can simplify before I solve, which is why we can always use PEMDAS on equations, but albeit I can only do it on one side or the other. When I want to move things across, that's when I start isolating the variable. I've got to cancel things out, which means we follow a slightly different, albeit very familiar form of PEMDAS. Okay? So once each side of an equation is simplified, we isolate the variable by using okay? Guess what? If you remember this from the last one, we isolate the variable by doing this process in reverse. Now this works specifically for like one variable. We're going to get into some of the exceptions and how to work around it when we have two variables or when we have things like exponentials or factoring. There's a lot of other ways to do this, but in the beginning, we're going to simply use this process quite literally in reverse. So when we use it, we called it SADMAP. Okay, and that's, again, PEMDAS in reverse. Awesome. So that highlights kind of where we're going to start out. So let's cover two different equations and see how we can simplify or how we can isolate and how the process is basically the same thing, and we'll get to the point where we can mix and match between the two. But in the beginning, we always, at least for the introductory, the way that I teach it, is we're going to start by simplifying the left and the right, and then we'll apply the isolation steps. Number one, we have 2x minus 13 equals 2. So 2.5x minus 13 equals 2. And for the second equation that we're working, I have negative 12 equals 9x minus 6x plus 15. Okay, So these are the two equations that we're going to be working. Now, I always like to draw the line down the equal sign. What that does is it separates expression 1 and expression 2. Because remember, I can simplify an expression using PEMDAS. So by drawing that line down, I know I can simplify the right-hand side. It's just the number 2. I can't do anything to that. However, the left-hand side, I'm going to see if I can't simplify anything. And I'm going to follow this exact order. I'm going to say parentheses, no. Exponents, no. Multiplication, division, yes. But I can't do anything about it. Because the multiplication, I'm multiplying 2.5 times this unknown value. Well, how do I multiply an unknown value by any number? I can't. So that makes it really hard to move beyond that step. I could add and subtract, but as long as it's not with this, because I can't do anything with that, and that's 13. So I can't simplify it, which means that this one, there is no simplification. We just start out simply with the reversal. So when we isolate a variable, we're going to start with removing the last step first. So any addition and subtraction. The addition and subtraction I see on this one, I notice my variable is on my left-hand side. I have a minus 13, which means that by isolating it, I do the opposite. I add 13. Okay? That's necessarily going to cancel it out. That's the reason why we did that. So I'm going to be left with 2.5x. 2.5x equals 15. Okay? The next step, what I see a lot of students do from this point is they'll do something like this. Don't do this. Is they'll say, okay, 2.5, I recognize that's a positive 2.5, and they'll subtract it from both sides, and they'll get x equals 12.5. And they'll say, hey, I'm done. What's wrong with that? Well, we forgot about the fact that 2.5 is not connected to my variable with addition or subtraction. And so remember, the three different operations that we're reviewing is addition and subtraction are opposites. Multiplication and division are opposites. Exponents and roots are opposites. Okay? So if the 2.5 is connected, pause, did you notice that? If you looked really closely, you notice there's a dot between that 2.5 and the x. It didn't look like it at first because it didn't look like there was anything. But if you look really closely, there's a dot between there. And that dot means multiplication. So do I get rid of multiplication by addition or subtraction? No, I get rid of it via division. So what I'm going to do is I'm going to say, hey, instead of subtracting that coefficient like a lot of students want to do, it's connected to the variable via multiplication. So we do multiplication by division. So I'm going to divide by 2.5. Okay? That's going to necessarily cancel out my coefficient because division and multiplication cancel each other out. And I'm going to be left with an x. So x equals, now for some of you, if you have a calculator, match that in, you're done. If you don't, I'm going to have to figure out some way to reduce 15 over 2.5 because this is ugly. We don't want to have a fraction and a decimal. Those are two different languages. A fraction is one way to show a ratio. A decimal is a different way to show a ratio because it's by a factor of 10. So we don't necessarily speak in two different languages in the middle of the sentence. We don't want to speak two different languages in our math answer. So I don't have a calculator to plug that in. Let's say I'm like, I don't necessarily know how many times 2.5 fits into 15. Hint, it's 6. So I'm going to have to reduce this. Hold on, I have a decimal. How do I get rid of a decimal? Well, I want to move the decimal over by one place, which means what do I multiply by? That's it, I multiply by 10. So I get 150 over 25. Now, for a lot of you, this looks a lot more friendly because you know how many times 25 fits into 150. 6. Let's say you don't, okay? So I'm like, okay, what can I reduce that by? Well, that reduces by 5. Both the 150 and the 25 divide by 5. So if I divide that by 5, I get 3, carry the 0, and I get 5. And now a lot of us at this point recognize, I know what 30 divided by 5 is, 6. So at any one of these points, if you recognize that the smaller number goes into the bigger number 6 times, you now have your final answer of x equals 6. Okay? So it doesn't matter at what part you notice it and get your answer, as long as you get your answer. So let's take a look at the next one. So the next one I'm dealing with, again, I want to try and simplify the left side and the right side because I have an expression, and I have an expression connected with an equal sign. So I have an expression, Anything I can simplify? No. I have an expression. Anything I can simplify? Yes, I can. I have a 9x minus 6x. Those do combine. So 9x minus 6x is going to give us 3x. So I have 3x plus 15. Bingo. I have simplified by using PEMDAS. Now, I did the addition subtraction. I probably should have said I checked for parentheses, none. I checked for exponents, none. I checked for multiplication and division. Well, I do have multiplication in those two steps, but I can't do anything with it. So I'll move to addition and subtraction and say, hey, I have an x term and I have an x term. Because every time I simplify, I start at p and end with a and s. So I'm trying to go through that every single time. Once I simplify, I look at the left and the right. Nothing else I can simplify. So now I'm going to go through and isolate the variable, which means I'm going to start peeling things off in reverse order. So the first thing I peel off in order to isolate that variable is addition and subtraction. I gotta find, is there anything on the side with my variable, which in this case is my right side, that is added or subtracted? And there is, it's a plus 15. So I'm gonna subtract 15. That's gonna necessarily cancel that out. And I'm gonna be left with negative 27 equals 3x. At this point, I'm gonna say, okay, I'm gonna again start at the beginning and try and peel my way back. So I'm going to check for anything else that I've added or subtracted. No. Anything else, I'm going to move to division and multiplication. Yes. If you look really, really, really closely, did you notice that there was a dot between the 3 and the x? I just noticed it because it didn't look like there was anything there before, but now that I'm really paying attention to it, I can see it. It's bright and it's red, and I'm like, oh, didn't know it's been there the entire time. So that's multiplication. In order to get rid of the multiplication, I'm going to divide both sides by 3. That's going to necessarily cancel that out. Remember, every time we perform one of these where we isolate, I have to keep the equation balanced. When I did it here, I did it to both sides. When I did it here, I did it to both sides. When I did it here, I did it to both sides. When I did it here, I did it to both sides. Was this an isolation step? No. So I don't do it to both sides. This is just simplifying. I'm only looking at the right-hand side. So again, make sure we're always doing it to both sides when we are isolating. So that gives me an x. The 27 divided by the 3 gives me the 9. The negative divided by a positive gives me a negative. Now, one of the things a lot of you get at is you say, hey, I don't like the x on the right. I want it to say x equals negative 9. And that's perfectly okay. Now, one of the things I'm going to recommend at the Algebra 1 level is, if you like writing like that, sure. Make sure it's a two-step process, though. Once you get to this part of your answer, then write x equals negative 9 as the second step and box that up. I don't care which one you put for Algebra 1. They're both right. The only reason why I say make this a two-step process is because your next course in geometry, when we do proofs and you have to do one step at a time, what you're going to have to do in the proof is state what you did each time. And I'm going to say, hey, I combined like terms. Hey, I used the subtraction property of equality. Hey, I use the division property of equality. You're going to have to state what you did every single step of the way. And once you get to this, how did your x end up on the left? You're going to be like, huh. Well, we're actually going to call that the symmetric property of equality when we get to geometry. So it's a good habit to get into. Leave the x on the right. If you really, really, really want it on the left, that's perfectly fine. I'll take both of these answers, but make it a two-step process so that next year you're not in a bad habit of skipping a step, which will cause you to throw off the entire proof. We don't need to worry about that right now, though, because this is good enough. So again, sometimes we move straight into the isolation part. Sometimes we can simplify and then move into the isolation. Some of you, though, are like, my teacher taught me differently in the last class. We just simply isolated. We never actually simplified the left and the right. Let's see. I have questions 3 and question 4. We're going to do the same problem 2 different ways. Actually, I lied. I told all my classes that these are 2 separate problems, and they were really confused until we did them 2 separate ways. So, if I did 2 parentheses 1 minus x plus 3 equals negative 8, and number 4 is this completely unrelated question, 2 1 minus x plus 3 equals negative 8. Again, completely unrelated, nothing to do with each other, right? Okay, so the first one, I'm going to draw my line right down the equal sign. That separates expression from expression. And I'm going to follow the same steps. Simplify the left and then isolate. So if I simplify the left, let's take a look. I'm gonna check, see, is there parentheses? Yes. Is there anything I can do inside of them? No. Any exponents? No. Well, for multiplication and division, I know parentheses tell me that I am going to be multiplying. Everything in those parentheses is getting multiplied by 2, which we call distribution. So I am distributing this 2 to both of those terms. 2 times 1 gives me 2. And I know in front of this x there's an invisible 1, so that's actually a negative 1x. So 2 times negative 1x is negative 2x. And then, do I distribute to that 3? No. That is not in the parentheses, so it's not implied multiplication. If I double the score of everybody in this room, do I double the score in the room next door? No, that's a different room. That's a different set of parentheses. This one's out in the hallway. Do I double the score of the people out there? No, that's in the hallway. So I leave it right there. Okay. The next step, again, I always start back over if I'm simplifying. I again check for parentheses. No. I again check for exponents. No. I again check for multiplication and division. Can't do anything with it. I'll then check for addition, subtractions. I'm going to look for some like terms. I do notice that I have a term right here and a term right here. I have a 2 and a 3. Now that 2 is a positive 2 and that 3 is a positive 3. So that's going to give me a positive 5. So I have a 5 minus 2x equals negative 8. So at this step, I have simplified the left and the right as far as I can. Now I'm going to move into the isolation step, which means identify the side that has my variable, left, and start pulling things off of it. I'm going to start with anything added or subtracted. Well, that 5 is added or subtracted to my x term. And here's the question. I'm going to ask, how do I get rid of it? Some of you might say, add the 5, because what you're noticing is you see, well, there's a minus sign right between the 5 and the 2x. That makes sense, right? Because the opposite of subtraction is addition, and they're connected via subtraction? Pause. What is that 2 connected, or what is that negative connected to? It's connected to the 2. What is the 5? The 5 is a positive 5. So even though a lot of you wanted to say, well, how about I add 5? No. That negative is connected to the 2. That's a plus 5. I need to subtract 5. So please be careful. Make sure that even though there's a minus sign between them, I know that it's a separate term. This 5 is a positive 5. I get rid of it by subtraction. Okay? And again, because I'm doing it, I'm isolating the variable. I'm going to do it to both sides. I subtract the 5, it cancels out, and I'm left with a negative 2x equals negative 13. This last step, again, I see a lot of students that negative, it really makes them do some weird things. With that negative 2x, a lot of what I see is I see students want to go ahead and add a 2 to cancel it out and say x equals negative 9, or sorry, can't add right there, negative 11. That's not the way we do it. Because again, notice how is that negative 2 and that x, how are they connected? Doesn't look like there's anything between them, right? Oh, silly me. If you look really closely, did you notice that there was a dot between them the entire time, or did you just now notice it? I just now noticed it. And what does a dot mean? A dot means multiplication. How do we undo multiplication? We undo it by division. So I divide by negative 2, and that leaves me with an answer of, what's negative 13 divided by negative 2? Well, negative makes it a positive. 13 divided by 2 is 13 divided by 2. Wait, Mr. Johnson, why'd you, that's 6.5. Why didn't you write 6.5? Well, that's because the general rule of high school math class. And now this is a rule that applies to like significant digits or how we round things. The rule that we apply in here is if the problem contains a decimal, then we can put a decimal in our answer. Does our problem contain a decimal? Nope. Doesn't matter if we encounter one later on. Does it originally have a decimal? No. So if not, we put our answer as an improper fraction. An improper fraction means no mixed numbers. I don't want 6 and 1/2. I want 13 halves, okay? The big thing is, if I can reduce this, I will reduce this. So I'm gonna put fully reduced. Okay, but I want improper fraction, and I want it fully reduced. So if I look back at my previous questions, if I had an answer on this one that was a decimal, could I keep a decimal? Yes, because there was a decimal in my original question. If my answer was a decimal, could I keep a decimal? No, because in my original question there was not a decimal. So we only keep decimals or create decimals if there's decimals in the question. And this stops us from rounding certain decimals to something that might get us in trouble later on. Because let's say my answer was like 1/3. Where do I round the decimal? Do I round it to 1, 2, 3? We can get in significant digits, but the idea is we want to get in a good habit. If there's a multi-step question, let's say this answer is the beginning part of the next one, I don't want to round, then work some, round again, work some, round again. That's a triple rounding error that can throw us way, way, way off. So again, our rule of thumb is if the question has a decimal, you can keep a decimal. You don't need to, you can leave a fraction. But if it doesn't have a decimal, you can't keep a decimal. So let's work this completely unrelated question number 4. I know, it looks so different from number 3. Okay, so Mr. Johnson, my teacher teaches something different. They taught it an entirely different way. We just isolate it every single time. Cool. Let's see if that gets us to the same answer. I'm going to not simplify either side. I'm simply going to start isolating the variable one piece at a time. Now again, the reason why I don't do this is because we'll notice that we'll get partway through and then we'll have to go backwards. And a lot of students, they're like, well, I should move all the way through, right? And this is why I don't tend to teach this method, but it's a completely valid method. So let's try it out. Remember, you always start from the beginning if you're using this method. No matter which one we do, we always start at the beginning if I'm simplifying or if I'm isolating. So starting at the beginning, I want to see, is there anything I can add or subtract away from my side with my variable? Well, that's my left side. Yes, I can subtract that 3. The 3 is added, so I'm going to subtract it. That goes away, and that leaves me with a 2 parentheses 1 minus x equals -11. Okay? The next thing I'll do is I'm going to start over. Start back here. Is there anything added or subtracted? No. Well, inside the parentheses, yeah, but pause. Where's the parentheses when we're isolating? Last. So don't do that. Start back over. Add or subtract? Nope. Multiply or divide? Yes. I do notice that because we have parentheses, that implies multiplication. So I'm going to say get rid of that times 2 by dividing by 2. That's going to necessarily get rid of that. And I'm going to be left with this 1 minus x, -11 halves. Now again, did I have a decimal in my original question? No, so I don't want to get in the habit of using a decimal. If there wasn't a decimal, I'm going to just get comfortable with working with fractions. Now, at this point, I got rid of the thing outside the parentheses. Is there any need for parentheses anymore? No, I can kind of ignore them. So let's go ahead and ghost that out. They're there, but because there's nothing to use them with, we can just ignore them. They don't exist anymore. Okay, so now I'm gonna, again, here's where the weird thing happens. I just undid multiplication and division. What theoretically should come next? Exponents? No, we always start at the beginning. So I have to start from addition and subtraction. And notice, guess what is now available? Yes, an addition or subtraction. So how do I get rid of that 1? If you said added, you just made the same mistake as we made over here. This 5 minus 2x, how do we get rid of the 5? We paid attention to the symbol in front of the 5, not what was separating it from the 2x. That separation tells us it's a different term. It doesn't tell us how to get rid of it. The 5 was positive. Now a lot of you might say add 1 because you're like, well, I see it's minus. But again,
What symbol is in front of the 1? That's a positive 1. What is the negative connected to? Well, the negative is connected to that 1, the invisible 1 sitting in front of the x. There are two 1s, one's a positive, one's a negative. What are we getting rid of? The positive 1. So we subtract 1. Subtract 1. That'll go away. I now have negative 1x equals, pause, I have a fraction minus a whole number. So what am I going to do? Unfortunately, I'm going to have to figure out how to subtract a whole number from a fraction. So I have negative 11 over 2 minus 1. Well, how do we do this? Well, we remember from working with fractions, the first thing we do is we always make every number a fraction. I'm going to put that over a 1. The next thing I do is I need a common denominator, which means those bottom numbers need to be equal. Common denominator is the least common multiple between the two of them. What's a multiple of 1 and a multiple of 2? Remember, multiple means count by 2s and count by 1s. So it's the first number you hit, 2. So I can keep that one, but this one I need to multiply the top and the bottom by 2 in order to get it to work. So if I do that, I'll get a negative 11 halves minus 2 over 2. And once I get something that looks like that, now what I can do is I can say negative 11 minus 2 all over 2, because they have a common denominator, so I can focus on the top. And what is negative 11 minus 2? That is negative 13 halves. Okay? Now the next thing that I'm going to do is I'm going to get rid of that coefficient. Again, don't add 1, because how is that negative 1 and that x connected? Well, if you didn't look very closely, you might have not noticed that dot that you now are paying attention to. Dot means multiplication. What is multiplication undone by? Division. That necessarily gets rid of that. I now have x equals, pause, wait for it. I have to divide a fraction by a whole number again. Oh no. So if I have to divide a fraction by a whole number, let's take a look at how I would do that. And you guys already know how to do this. I have a negative 13 over 2, negative 13 over 2, all divided by negative 1. Well, in order to divide a fraction by something else, I have to make that number also a fraction. And then if I divide fractions, what 3-letter word do we use? KCF, keep, change, flip. Keep the first one, negative 13 halves, change that to multiplication, and then flip the second fraction. That will become 1 over negative 1. Now that it's a multiplication process, I multiply straight across. This will give me a negative 13 over a negative 2. What's a negative divided by a negative? Positive. That will give me a positive 13 over 2. So, can I change the order of these steps? Yes. I like to teach simplify and then isolate, simply because it provides a more uniform approach. Can you isolate? Yes. I feel like with the isolation part, when we're working our way down, it's really hard to get students to remember we have to start at the beginning each time, and they want to just move throughout. So that's why I teach this and then this. However, if you like isolating, did we get to the same answer? Yes. The analogy I made in class is, doesn't matter what road you're driving on, everybody follows the same rules of the road. If you are simplifying an expression, what must you follow? What order must you go in? PEMDAS, you have to go in that order every single time. Start from the beginning. If you're following this method, you take a different route to work, a different route to school. What order do you have to follow when you're isolating? Yes, I do it in reverse every single time. So no matter which route you take, you're following the same rules of the road. You stop at stop signs, you stop at red lights. Some of you will slow down at yellow lights. Some of you means that hits the gas and you just speed up. You always use your blinker at turns. We're all following the same rules, even if we're taking slightly different routes. Let's take a look at the last two questions before we tie things up. Okay. Number 5 and number 6. Number 5 is 2x. 5 minus 3 minus 3x equals 5. And number 6 is 17 equals 7 plus 4, 2.2d minus 8.5. Okay. Now we're going to do both of these in whatever order feels most natural. If you want to do it all using this, or if we want to kind of bounce back and forth, remember, what do we always do? We start at the beginning and work our way through. If I'm simplifying, go in this order. If I'm isolating, go in that order. So on number 5, let's take a look. Now, I could try to isolate, however, it looks like there's some really easy stuff that I could do inside the parentheses. Remember, start with P, PEMDAS, inside the parentheses. Do I know what 5 minus 3 is? Yeah, 5 minus 3 is 2, so I have 2x times 2 minus 3x equals 5. Again, start back at the beginning. Anything I can do inside the parentheses? No. Exponents? No. Multiplication, division? Yes. I know 2x times 2 is going to give me a 4x. Start back at the beginning. Parentheses? No. Exponents? No. Multiplication, division? I could try, but I don't know them yet. So I'm going to move to addition, subtraction. I found 2 like terms. 4x minus 3x gives me 1x equals 5. Do I need to write the 1? No. So I'm going to ghost it out. If you have it, if you don't, it can be there. It doesn't need to be there because guess what? That is your answer. Okay. So again, you always start at the beginning and work your way through. Number 6. Again, I don't need to follow this order and then that order. That's typically the way I do things. But if you're like, you know what? I immediately want to get rid of something because I see that that 7 is hanging off the edge. Well, pause. With the isolation step, a lot of people want to do addition subtraction first, and this is what they want to do. They want to say, let's go ahead and add 7 and 4 and make 11. Because they're like, well, that makes the distribution a lot easier, right? Because I can simplify using PEMDAS, addition and subtraction. No, what does PEMDAS say you have to do first? PEMDAS says you have to multiply before you add or subtract. So if you're following PEMDAS, do it in that order, which means I cannot add, I have to multiply. But I don't want to multiply first. I want to do something slightly different. If I want to isolate part of it, I can get rid of the addition or subtraction before I simplify. Okay, what does that mean? Anything added or subtracted, this 7, I'm going to subtract this 7. Okay, that's going to cancel that over here. I will have a 10 equals 4 times 2.2d minus 8.5. Now again, I have a choice. I can either isolate or I can simplify. It doesn't matter which one you do, but again, you have to start at the beginning. Now, if I isolated, I don't have anything to add or subtract, but I do have a multiplication division, which means I would divide by 4. I'm not going to do that because if I divide by 4, 10 doesn't divide by 4 evenly. I'll have a fraction over here and some decimals over here. I'd like to try to avoid that. So what I'm going to do is I'm instead going to follow PEMDAS first. I'm going to say parentheses, can't do anything inside of them, exponents none, but I can multiply this 4 times everything inside those parentheses, which means that and that get multiplied by 4. So I have a 10 equals 8.8d minus, if you don't know how to work this, if you don't have a calculator, you gotta work this by hand. That is 8.5 times 4. 5 times 4 gives me 20, carry the 2. 8 times 4 gives me 32, plus the 2, 34. There's 1 decimal in my question, which means there's 1 decimal in my answer. That's 34.0, or just plain old 34. Okay, so far so good. You see how I actually did this before I did that, but I'm always following it in that order. That's the key point that we're really trying to drive home right here. Okay? So it's in that order. At this point, there's nothing I can simplify, nothing I can simplify. I've gotta follow the isolation part, which means again, start in that order. Addition or subtraction. Yes, I have a minus 34 because my variable is on this side. I'm gonna add 34, add 34, cancel that out, and that will leave me with a 44 equals 8.8d. And again, when I get to this point, I know the 8.8 is going to be multiplied by the d, so I'm going to divide by 8.8, divide by 8.8, and what I get is I get a fraction that I have to work over here. If you hear a noise like that, that means somebody's trying to walk in or out of the classroom. It happens. I'm not gonna edit that out, so we're just gonna keep going. So the 44 over 88, this is really tempting to say, well, 4 and 4 divided by 8 and 8, I should get 1 and 1 over 2 and 2. That makes sense, right? It's 1/2. But maybe there's a decimal in there somewhere. Be careful with this, because with a decimal, again, that's a different language, it might not translate very well. So in order to get rid of that decimal, I'm gonna move everything over by 1, which means I'm multiplying by what? By 10. So I'm gonna multiply by 10, so 440 divided by 88. And we're like, oh, I'm glad I didn't do that because there's a 0 there. That doesn't work out with the 1s and the 2s, but I do notice 4 and 4, 8 and 8, they all divide by 4. So if I divide by 4, I get 1 and 1, and I get 2 and 2. So I still see my 1s and my 2s, but that 0, I'm glad I didn't do that. Because at this point I would say, oh, those are both even numbers, let me divide by 2, 55 divided by 11. At this point I'm like, oh hey, what is 55 divided by 11? 5. So that tells me that my answer to this question is 5 is equal to D. Okay? Now if you really want to put D equals 5, where you put the variable on the left, remember, the D was on the right, stays on the right. If I want to put it on the left, it's got to be a 2-part where then I say D equals 5 as the secondary answer. Again, however, you can just stop right there. So the next thing that I'm going to do when we finish these is I'm going to put up what the homework is in case you missed the homework. Tonight's homework is, where do I want to put it? Put it right there. It's actually already listed on the board over there, like smushed in the corner. It's currently listed in the classroom, up in the top corner on the whiteboard over there. Can't see it in this shot, but I'm going to write it on the board over here. So for section 1.2, the homework is page 16, numbers 1 through 12, even. I know, super difficult problem set. Homework for 1.2 is this. It's page 16, numbers 1 through 12 even. That is 6 questions. Knock those out. Those 6 questions should take all of, guess what? 6 minutes. But with those we do tomorrow, make sure you knock those out, and I'll see you for the next one.